In this paper, we present a novel framework for improving the realism when performing guided image synthesis. In particular, we look at the problem of guided image synthesis given a text prompt and a reference image, usually containing coarse user scribbles. The prior work in this direction often suffers from the problem of having insufficient details in the generated image outputs. For instance, let's say a user is trying to generate a photo of a beautiful landscape. Then typical text condition image outputs correspond to realistic photos of beautiful landscapes. However, when providing an additional reference input, we see that prior works typically lead to outputs which are less detailed and resemble simple pictorial arts instead of realistic photos. Our work aims to address this problem by instead allowing users to generate significantly more realistic content corresponding to input user scribbles. Additionally, our framework also allows the user to specify the semantics of different painting regions. In particular, given a text prompt and a reference image provided by the user, we first define a target subspace, which is the set of all images conditioned only on the text prompt. In this case, it would be the set of all images containing photos of a red tiger in a green field. Once we have defined this subspace, we now formulate the output of the guided image synthesis process as the solution to a constraint optimization problem with two constraints. First, we want to ensure that the output image lies in this target data subspace. This ensures that the output image is actually a realistic photo of a red tiger in a green field instead of being simple pictorial art. And second, we want to ensure that if we paint the output image using an autonomous painting function, then the resulting image should be as similar as possible with the original reference input that is provided by the user. While computing an exact solution of this optimization is not directly feasible, we propose a simple two-step approach towards obtaining an approximate solution. First, we solve an unconstrained approximation of the original optimization to obtain an initial estimate of the output solution, x star tilde. This x star tilde has two main properties. First, it is closer to the target subspace in the latent space C. And second, it still maintains faithfulness with the original reference input that is provided by the user. Once we have obtained such an initial estimate, we can then perform DDM inversion on this initial estimate in order to obtain our final image output. Creating a parallel with prior work, we note that prior works such as STEdit operate by directly performing the inversion operation on the reference painting Y. Since the original reference input typically has a high domain with the target subspace, this leads to outputs which typically lack details which are characteristic of the target data subspace. In contrast, by first computing an initial estimate for the solution x star tilde, which is much more closer to the target data subspace, the use of the DDM operation now allows us to generate outputs which are significantly more realistic, yet maintain faithfulness with the original reference input. We show the efficacy of the proposed approach on a diverse range of guidance inputs. For instance, for a red bird in a tree, we observe that STEdit typically leads to simple pictorial arts instead of realistic images which are found in the target subspace. The reuse of STEdit outputs in an iterative loopback strategy has also been explored. However, we observe that it is computationally expensive, and as the number of iterations increase, the faithfulness with the original reference painting is compromised. In this example, we observe that the green boundary of the tree region is compromised as the number of iterations increase. In contrast, GradOp is able to generate outputs which are significantly more realistic and yet maintain faithfulness with the original reference input. In another example, this time for a photo of a blue elephant in a field, we observe that the STEdit outputs again are cartoon-like images. GradOp is able to address this problem by generating significantly more realistic output content corresponding to the input reference. We also compare the performance of our approach with SDEdit under varying hyperparameter selection. Here we observe that for low values of DO, the generated outputs are faithful yet unrealistic. For high values of DO, the generated outputs are more realistic, but they lose faithfulness with the original reference input. At the same time, GradOp is able to generate images which are both realistic and maintain faithfulness with the original reference image. Finally, in addition to just performing photorealistic image synthesis, we also observe that the GradOp approach is highly generalizable across a range of target domains, such as Van Gogh painting, children drawing, watercolor painting, and so on and so forth. While the proposed approach allows for the generation of image outputs with improved realism, we find that sometimes the semantics of different painting regions might not accurately reflect the user's true intent. For instance, in this example, the yellow region in the sky can also be inferred as a yellow-orange tree instead of the sun. Similarly, certain painting regions might be entirely omitted if the model does not understand that it corresponds to a separate semantic entity. To solve this problem, we take motivation from the observation that when generated faithfully, the cross-attention maps across the reverse diffusion process show high overlap with the semantic segmentation for different entities. In our experiments, we found the reverse to also be true. That is, by constraining an overlap between the binary mask for a particular painting region, in this case a hut, and the corresponding cross-attention map, the user can control the semantics of different painting regions in a much better manner. For instance, the user may choose to provide the semantics for a single object, in this case, a hut. Or optionally, the user may also choose to provide a much more detailed semantic guide in order to describe what each painting region corresponds to. Our project page and demo are available online. For more information, please read our paper or visit our poster session. Thank you for listening.